Hi, this is Stuart again. We're going to talk about cloud logging best practices. So the first thing we want to do is to put our best practice into the context of an even better set of best practices, the 12-factor net group, which essentially has a polemic about, scratch that. 12-factor net is a group of people who have put together a manifesto on what it takes for software systems to be genuinely cloud ready. We're going to do some other talks about this, but we want to start with their manifesto on logging. So let's talk about what we would like logging to be in the 12-factor universe. Essentially, a stream or uninterrupted series of messages that are in time order that contain useful information. And we want to disassociate from our application any linkage to where the messages go. In other words, we want our application to put out messages out into the world, but we don't want to care about the specifics of what, if anything, is going to catch those messages, how they're going to be handled, and what happens to them downstream. In other words, we want to make it so that the application is only responsible to producing log streams and nothing else. Everything else is somebody else's problem. And in the cloud, this is pretty easy to do because most clouds have a structure that supports this model. In other words, your app writes good things to standard out and bad things to standard error. They're passed through from your hosting provider. Your hosting provider may also emit events in state of its own. Those typically flow to an aggregator. That data then flows to some sort of analyzer. And then we like to see the output of that on some sort of dashboard. And we want to take actions on that data based on some sort of event handler. So here's a typical scenario. Pivotal Cloud Foundry, for example, has an aggregator to which we can attach a nozzle, which will send our log streams out to, for example, Elk. And in the Elk suite of tools, you can build dashboards and arrange for events and so on. Commercial products exist. For example, Datadog, which actually allows you to do the reverse, which is to put in an agent into your host or your cloud and pump that data into the big orange box, the Datadog. If you're on Azure, for example, you can use application insights and then roll those into Ops Manager, and you get the same sort of dashboarding and event handling. But you'll notice that all the way to the left, our app is only concerned with writing good things to standard out, bad things to standard error. So we've built up some guidance, right? The value proposition of the guidance that we have is centralize your logging somehow. I'm primarily a C# developer, a .NET developer, so I typically get my reusable libraries off of NuGet packages, and we want to centralize all of the logging so that we can do three important things. First is we want to break logs into categories, and we're going to get into that in a minute. The second is that we want to make sure that logs and other diagnostic information are always written in the same way in the same format. And third, if we later on decide we want to rip out our logging plumbing, we don't have to rewrite our code. In other words, our code's going to call our logging facade, and our logging facade is going to be fungible so that we can plug stuff in that does the actual log emission and formatting. The next thing we want to do is we want to avoid conflating standard error and standard out. Bad things go to standard error. Okay things go to standard out. You want to avoid buffering of any kind, right? In the definition provided by 12 factor, we say that we want logs to be streams. By definition, streams aren't buffered. If you're buffering log messages and your app crashes, you're going to lose that buffer and you're not going to be able to tell what went wrong as easily. We want to avoid writing logs to things like the file system, right? Particularly in container systems like Kubernetes and PCF, but also on virtual machines, anything, right? We want to avoid writing things to the file system. We want to also avoid writing logs to anywhere that might not be highly available. So if we're going to do that, right, if we're going to use a database or NoSQL to be our log stash or some exterior file system or cloud native storage or whatever, we need to make sure that there's some sort of way of making sure those things are extremely, very highly available, or that there's some sort of retry, which sort of goes against buffering, right? We really don't want our apps to have to manage the log stream. So what we really want to do is make sure the things consuming our log streams are bulletproof. And we'll talk about log stream types in a minute. So here are what I would call standard logging levels. And if you were to collect a group of dev and security professionals into a room, DevOps people into a room, they might disagree on the exact name of these log categories. But what they wouldn't disagree about would be how the categories are organized and what they mean. So fatal is sometimes called critical. Error could be called exception. Warning could be called oopsie doodle. We don't care. What we care about is that our log stream should be tagged or enriched, right, with a log category that lets us separate out these use cases. And so, for example, the topmost use case is should only ever be used by your application to indicate that your app could not run no matter how many times you restart it. So, for example, transitory failures like the app can't find your database server shouldn't ever be fatal. But the fact that your application goes to its configuration source and can't find the connection string to your database, that is fatal. Likewise, it's fatal if your application has dependencies that are in code or in libraries that you can't find and so on. The fact that your application cannot connect to some exterior resource, what the 12-factor folks call a service, is an error. And errors are broken down by errors we couldn't handle and we had to sort of restart or abandon that request or whatever and return an error or just halt processing and go back to the beginning and try again. Those are errors. On the other hand, if we have a recoverable error, that is to say we caught the error and we did things and then our business process or unit of work could continue, it's not an error, it's a warning. And notice that that distinction is important because we transition from writing to standard error to standard output. Info or information, or one of its synonyms, is reserved for messages that would be of interest to the user or the business community. For example, logging that you received a new order from the XYZ Corp, or that you have done some photo processing as part of Order 741 or whatever. Debugging and trace messages are for the developers and for the folks who respond to incidents. And so Generally speaking, they're turned off. And if we think our system is starting to have problems, we turn them on. And many systems have a subtle differentiation between terse messages and verbose ones. And that's the difference between debug and trace in this example. Okay, let's go look at an example in C#. You can go pull the code down that I'm going to show you from my GitHub site. And just because this example is in C# doesn't mean that there aren't equivalent things in Java, JavaScript, Go, PHP, Perl, and so on. Here's a little example in C#.NET implemented in .NET Core. So this should work on Windows or Linux and pretty much any cloud. In main, what we're going to do is build up our DI container, and we're going to add configuration and logging, and of course the unit of work we're going to execute, which is a little service called the log maker service. It's just going to generate logs of different types. And then we're going to get our service instance from our DI container and execute its run method. Pretty straightforward. So what's interesting in console apps is that instead of a lot of this plumbing being pre-generated for you, as it is in ASP.NET apps, for web API or for UIs, we have to do some heavy lifting for ourselves. So this is kind of handy code to have. The heart of the startup procedure is called configure services, this method right here. And we're going to jump to it and walk through it ever so briefly. So in this case, I want to be able to get my configuration from either environment variables, which would be suitable in Kubernetes or Pivotal Cloud Foundry, or I want to be able to get them from the command line, which is handy if, as we are here, testing from inside our IDE, or we have set it up to run as a service on a VM or whatever. So we get our environment variables and then we overload those with the command line arguments if we need to Bigfoot them. And then we make sure that to our DI container, we add the configuration as a singleton, because we want to make sure there's only one copy of our configuration running around. Setting up logging is not much harder. And instead of using log factory, we're instead going to use the new method in .NET Core 2.1 and higher. In this case, we have .NET 2.2. Of using the add logging override with a function constructor that is going to set up our logging. And so in this case, we're going to set up our minimum log level for the purposes of demonstration. And by the way, one of the things that frustrates people who are using Microsoft.extensions.logging, which is the logging library I'm using here, is that you actually have to make sure that statement is first. And then we're going to add our console log listener, which is generally pretty friendly for all cloud things. And then if we're on Windows OS or Azure, or if we're implementing things as a function up on Azure or any other Windows-friendly host, it's nice to add the debugging sync. And that, of course, is going to system.diagnostics.trace. So that's interesting. And then, of course, we're going to say, well, as part of configuring my DI container, I want to add a transient service in the form of iLogMaker service, of LogMaker service. And what does transient mean? Transient means that every time I go to ask for an instance of my LogMaker service, I'm going to get a new one. And that's generally the appropriate behavior for classes that aren't static. But there are other choices, and you can go look and read all about Microsoft's DI container. So inside my LogMaker service, I am going to have a constructor that injects iLogger of LogMaker service. Notice here I'm using Microsoft.extensions.logging, and the reason that I have to make sure that I'm injecting a strongly typed logger is that the dependency injection mechanism no longer respects the generic or typeless iLogger. You have to be specific, and the easiest way to be specific is to just inject a logger that you want to be of the class that the logger is servicing. We're also going to inject the root, put those into our class level variables, and then in the run method that we invoked from our program, what we want to do is, in this case, I am just looping over this a certain number of times. How am I getting that? I'm getting it by pulling it out of my configuration, which came from either an environment variable or a config in this case, or I could have a JSON configuration file, whatever I wanted to do, and how long I'm going to wait between each step. And then I'm just going to dump all the configuration that I absorbed. And then I made a little dumb helper that emits a bunch of different kinds of log messages. And so when we run this, and in this case, since it's going to the Windows console, they're color-coded and formatted, but normally these things would just flow out as a stream and we can interpret them. My name is Stuart Williams, and I work for Magenic.